Perfect. Now, just checking, can you hear me?
All good, Clodagh.
Great. So I'm going to be covering off Tully. I'll explain what that is in a minute. The meat eating quality and basically the role of genetics in reducing greenhouse gas emissions as well. So what is Tully? Tully is the ICBF Progeny Performance Test Centre, and it's located just outside Kildare town in County Kildare. You can see it on a map there with the little star, and it's been in existence for almost 50 years. So it's a small site. It's about 11 acres in total, and it was formerly a test centre for young pedigree bulls, which were brought for feed intake recording as a Department of Agriculture facility. So now it actually operates as a commercial feedlot for progeny testing, the progeny of the Gene Ireland bulls. So those progeny are coming from both dairy and beef herds, and these animals are being kept indoors for an intensive finishing period. And while the test centre operates as a commercial farm, there's a large emphasis put on data recording. So you can actually see in the image here, it's not a massive site, but there's 3 main sheds. 2 of those sheds that you can kind of see off in the background are duplicate layouts, so they're the exact same shed. And the shed to the foreground of the picture is recently adapted. It was a recently adapted shed just to maximise the throughput of animals through the facility. So what was the main role of Tully initially? So it was to collect data on hard to record and expensive traits. So that would have started out with feed intake, even back into the 70s and 80s. But that's moved on to meat quality, greenhouse gases on the progeny of those AI sires of interest. So those are the Gene Ireland bulls. We aim to get maybe 20 progeny per bull across steers, heifers and young bulls. And these animals are sourced directly from farms who would have recorded the early life information such as their calving difficulty and some live weights as well. So there's about 650 animals slaughtered annually from this facility, with 55% of those coming from the suckler herd and 45% from dairy dams, so a mix of dairy animals and dairy beef animals as well. Those intake groups of animals that we get, they're quite tight in age as well, so there's no more than 2 months in the age difference between any of the animals coming into the facility. So all of the information that's recorded in this test centre flows into the evaluations and ultimately into the breeding programme. So just to give you a quick run through of the process in Tully. So animals get acclimatised for 30 days. So that allows time for vaccination protocols and adaptation to diet. That diet consists of ad lib concentrates for young bulls, with hay as well, just to ensure digestive health. The steers and heifers then get a total mixed ration, which is a mixture of concentrates and hay as well. So then the focus shifts to the data recording, including recording multiple live weights to calculate average daily gains. The feed intake is measured. Animals are linear scored for muscle, skeletal and functionality traits. I suppose the unusual thing here is we're recording all those on crossbred animals. In the case of young bulls, scrotal circumference is measured. And also there's ultrasound scanning of muscle depth, fat depth, and the intramuscular fat of the live animal. Health and disease traits then are recorded as well in the animal's time in Tully. Pneumonia, lameness being recorded, and also checking for any visible genetic defects. So Ross would have talked about genotyping. All of these animals are genotyped on our customised chip. At the very minimum, they're SIRE verified. Where there's DAM genotypes available, they're also DAM verified too. So the age at slaughter then for the animals coming through this facility, it varies by carcass type, but I suppose for the bulls and the heifers, it's around 15 to 18 months. And then the steers slightly older at 17 to 26 months. I suppose you have to remember there's a variety of animals through each of those categories. So for feed intake then, so feed intake is the trait that's been recorded for the longest time in Tully. So the animals are getting, well, apart from the young bulls, they were getting a TMR, total mixed ration of 14% hay, 45% concentrates, 40% water, just for ease of feeding. And I suppose the metabolizable energy, maybe that's of interest to people, it's around 12.1 megajoules as well, assuming a 51% dry matter. So in terms of the actual measurement then, it's being measured by an Instantech feed system. So you can see those blue boxes in the pictures. Hopefully, I hope my little picture isn't over it. So you can see them there. There's weigh cells underneath all of those. So the animal comes to the feed bin. They have an RFID tag or an EID tag in their ear, which identifies the animal, and it measures the kilograms of feed consumed for each visit, and it syncs to the database daily. So ensuring the relevance then of this feed intake in the finishing period, it gets scaled to a lifetime feed intake, which feeds into our national evaluations, with feed intake PTAs being published for all animals routinely as part of the profit index Siobhan would have mentioned earlier. So in terms of meat eating quality then, so when the animals actually leave the facility in Tully, they go directly for slaughter, where carcass weight, conformation and fat, conformation grade and fat scores are recorded. Primal yields then are recorded after a 48-hour hang time, and then the carcass is actually split into 19 different cuts. And additionally, pH is measured in the 48-hour period, hourly and with a final pH. I suppose pH being a useful metric for farmers and processors, and also consumers, because it can be driven by stress levels prior to slaughter for the farmers, that's important for the farmer to know. It also has an impact on product processing, so processors don't want high pH animals or stressed animals coming in. It shortens shelf life, and I'm sure if you saw any of the steaks on the right hand side of that on a shop shelf, you wouldn't be buying them. So it has an important role in consumer perception as well. So in terms of our meat eating quality then, to date we actually have data on over 8,000 animals, and on each animal there's they've recorded the colour of the loin, the visual marbling has been observed, composition analysis was carried out as well, including the intramuscular fat percentage, the protein percentage and the moisture percentage, and cook loss, and it was measured along with mechanical shear force also. Samples then get sent, so obviously the loin is staked, and those samples get sent for sensory analysis. So there's two main sources of information there, being trained objective panels sent for sensory analysis, and also there's a private company involved in that space as well. So work is ongoing to get direct measures from consumers also, but the main three traits that are being focused on are flavour, juiciness and tenderness. And this actually PTA is published for beef AI bulls on ICBF.com routinely, so you can have a look at those there. So just in terms of what do those PTAs look like, I suppose if we just focus in on one of those traits, I won't go through them all, specifically tenderness, you can see here that the Angus performs quite well. The red dot there indicates the average, but it is still a trait that needs a lot of attention. As you can see, the range of PTAs observed in other breeds are quite comparable with that of the Angus. So, you know, it's important to keep an eye on the length of that bar as well. So methane production, I'm doing a PhD in methane, so I could talk about it for hours, but I'll give you a quick summary first. Just in terms of how it's produced. So an animal consumes plant material, which is broken down in the rumen. One of the resulting byproducts is methane. When the animal eructates or burps, the gas comes out. So about 90 to 95% of the gas is coming out of the mouth of the animal. And, you know, reductions in methane improve environmental sustainability. There's about a 2 to 12% gross energy loss from the whole process of manufacturing methane. And it'll also increase economic sustainability if you can reduce methane production as well. So we're actually measuring methane in Tully. We have 10 green feed machines, so there's 10 different opportunities for these animals to actually record their methane. They measure a gas flux measurement for methane and carbon dioxide, and it gives a grams per day figure for each visit the animal makes to the machine. What's quite unusual, I suppose, about Tully is the animals have to visit the machine independently. You can see that animal down there the last days. I didn't have an Angus, unfortunately. So they visit to the machine. It's of their own free will, so that they have to come to the machine independently. So if you get 1 grams per day figure, you could also get 3. A bait feed gets dropped from these machines to keep the animal there. So every 30 seconds, basically for 2 to 3 minutes, to keep them at the machine to get a good record of methane. So identification here, again, the same RFID tag works on these machines, and the data gets synced to the cloud routinely after visits. And it's a really non-invasive process for animals, and it only causes a minor impact on animal behaviour. In terms of what daily emissions look like, I suppose we all talk about methane and from livestock, but what does that actually look like? Well, it depends on the time of day. So we talk about the diurnal pattern, but if an animal's methane is actually recorded between 5 a.m. and 10 a.m., it seems quite low with 204 grams per day on average. In comparison, an evening measurement has nearly 100 grams higher at 302 grams per day. So we just need to be careful of the time of day that we are measuring these animals, and if the animals are visiting the machine independently, how often they actually visit that machine is important too. So following on from how important that is about their visit frequency, there's been a lot of research in Tully in relation to how long a test period for methane measurement needs to be and what impact that visit frequency to the green feed machine has on the repeatability of the measure. So the higher the repeatability of a measure, the less measures you need. So we looked at a subset of animals here. There were steers that passed through Tully. And when we stratified the data into what we considered good, average and poor visitors to the green feed machine, we can see that it takes a longer amount of time for poor visitors to achieve acceptable levels of repeatability. But from the phenotypic analysis, we can kind of see that irrespective of the visit frequency, that the 10-day test period appears to be sufficient. However, if anyone was trying to do this, I would definitely recommend caution and probably keep them on test for a lot longer. The added cost for keeping them on test for a couple of days pales in significance to inaccurate measures. So Siobhan would have mentioned the importance of heritability when setting out breeding objectives. And there's been no general consensus, I suppose, in terms of what methane trait definition we should use if we want to breed animals for reduced methane. What we have here on the left of this graph, you can see I've included live weight and dry matter intake. They're two traits that people might be a little bit more familiar with. But the heritability for the greenhouse gas traits ranges from 0.11 for a methane yield type trait, right the way up to 0.34 for carbon dioxide. There's 3 residual type methane traits, and our gross methane trait is coming in around a heritability of 0.21. If we look then at some of the phenotypic correlations, we'll see strong relationships between methane and related traits such as methane yield or methane intensity, depending on how you quantify that for live weight or carcass weight, and a residual type methane trait as well. What we did see that was quite surprising is, I suppose, that lower correlation or that lower phenotypic correlation between methane and dry matter intake of about 0.31 there. I suppose it actually has a lot to do with the multi-breed nature of the data set. But if we look at the genetic correlation in comparison, the genetic correlation between methane and dry matter intake is sitting at around 0.72. So, you know, it leaves scope for selection based on either trait to improve environmental sustainability. So we actually followed those methane phenotypes through to methane EBVs, and while still very much at a test phase, the initial analysis shows across and within breed differences at sire level. So if we look here at those Angus sires, they're those purple dots, we can see that there are a few sires there on the left that, regardless of trait definition, they consistently rank lower on methane EBV, meaning they'll produce progeny with less methane irrespective of your trait definition. So look, they're very much at a test stage, but they're definitely a very real and potential mitigation strategy to reduce methane output. So just kind of one of my final points here, if we look at some of the phenotypic data coming out of Tully, Siobhan went through the terminal index. Obviously, these animals are destined for slaughter, so it's the most relevant. But if we look at a 5-star animal, which is your top 20% of animals, compared to your bottom 20% animals, which are 1 stars, you can see that they actually produce phenotypically on a daily basis 36 grams less methane for the 5-star animals. If we look at their feed intake, those 5-star animals are eating about 1 kilo less of feed. Their final live weight is pretty comparable. I suppose they're being finished to certain specifications for slaughter. So there's no real difference there. But where these animals really start to pull apart is the difference in carcass weight. So there's actually 36 kilos in the difference of carcass weight. And where that's coming from is the 6% difference in kill out between those 5-star animals and those 1-star animals. In terms of carcass conformation then, you can see that those 5-star animals are consistently killing out better than those 1-star animals. And at age slaughter, they're actually being killed 22 days earlier as well. So there's a reduction in feed cost each day with that. And also on 100, if you were to take beef at being €5 a kilo, it's probably not as good at that as when I was putting this slide together, but it's €180 in carcass value of a difference between a 5-star terminal steer and a 1-star terminal steer. And the trends are similar across all the different carcass types. So that was just, it's a small subset of animals, but there were just 317 suckler steers that had methane and performance data available on them. So just kind of lastly, I suppose Tully has come a long way since when it started. What the hope is now is to actually install water troughs to include collection of water consumption on an individual animal level. Water availability is going to be a big issue going forward across the world, and all the research points towards that. We'll also be installing sensor tags as well, just to get an idea of rumination time, because that's quite strongly linked with those greenhouse gas traits. And also there's a little bit of a conversion process going on. When these animals are being recorded for feed intake, they obviously can't have bedding that they can consume. So those peat beds are no longer going to be viable for availability or sustainability issues. So there's just been a move there from slats and scrapers. So that's it for me. I'll keep it quick.